deal with all this mess.
Solutions.
Now, to bring us on the path towards solutions, I need to introduce one more system called DNS. Show of hands again. Who here knows what DNS is and what those 3 letters stand for? Okay, about 60% of you raise your hands. DNS stands for Domain Name System. And what is it? All it is it's a key value mapping, or just, a mapping from names to IP addresses. I probably shouldn't ask this question because you probably all know, well, I'm not going to bias the answer. Who here knows what IP addresses are? Raise your hands. Okay, just about everybody raise their hands, and the people who didn't probably know.
The question is, at what level, do you want? Always fuzzy, like.
Okay,
what level do you want to know what IP address is?
Well, okay, so IP addresses, like many computer people know, are how you find computers online. They are the primary means with which you find a computer through a network. And the reason why we have DNS is because few people are capable of memorizing numbers, just arbitrary numbers for whatever websites. And also, numbers are not very conducive to brands. Numbers are usually associated with prisoners, not brands. So if you want, like to have a nice brand online, you probably don't want it to be a number. You probably want your people to rally around a name. And that also helps people find you, because names are far more memorable than numbers. We're humans for whatever reason. We're not calculators for some reason. So when Alice tries to go to Facebook.com, the first thing she probably does is she either clicks on a link to Facebook.com or she actually types Facebook.com into her web browser. And then it's up to DNS to find out what the IP address is of Facebook.com. Now, DNS is a hierarchical system. There are a bunch of TLDs at the top. And TLDs stand for top-level domains. These are things like .com, .org, et cetera, et cetera, et cetera. And at the very top of the internet, there are a dozen servers or so that manage these top-level domains. And they know they have a registry to other name servers that are responsible for things like Facebook.com. I don't know why I keep using Facebook.com. Well, just continuing the story. So, it just shows Zuckerberg is really good with his marketing. So, Alice asks for Facebook.com. Some name server here sends over an IP address. A DNS server sends over an IP address. And again, you have the man-in-the-middle attack. What happens if, when you ask for Facebook.com, you're given the IP address of some other malicious server that looks like Facebook.com, or for a bank that looks like Facebook.com? Long story short, because I want to bring us to solutions more quickly, DNS is actually not a big deal. It's not a big deal if the DNS server lies to you about what Facebook.com's IP address is. It's only a big deal when you're dealing in two situations. When you're connecting to a website over HTTP, or if an attack called SSL stripping is being used on you. Let me briefly describe how that attack works. So Facebook.com now, thankfully, uses HTTPS by default. A few years ago, they didn't. They used HTTP, and then a DNS man-in-the-middle attack could be fatal because users have no way of distinguishing between a legitimate server and a non-legitimate server. And they added HTTPS. Unfortunately, there's an attack called SSL stripping, which is where a man-in-the-middle establishes an HTTPS connection this way to Facebook.com, and then gives to you an HTTP connection to Facebook.com. So they're able to read everything in plain text, and so is everybody else in the cafe. And then they just re-encrypt it, as though they were you to Facebook.com. They pretend to be you. And the user experience, the user point of view, what the user sees is they see Facebook.com in the web browser without a lock. Unfortunately, most users aren't going to notice this. So they invented a thing called HSTS, which is something or other, something state, I don't remember what it stands for. Which is basically Facebook.com, when you visit it once, says, for the next year, web browser, I only allow you to access me over HTTPS. Never, ever can you ever access me over HTTP for about a year or so, whatever they set the timeout for. And that actually does help a whole lot prevent SSL stripping attacks. Because when a user just once visits Facebook over HTTPS, then from that point on, for the duration of that little timeout, they cannot visit it over HTTP again in that particular web browser. It has to be done for each web browser that they use. Okay, so why is DNS man in the middle not a problem when HTTPS is actually being used? The reason is because if somebody gives you the IP address of not Facebook servers when you ask for it over DNS, let's say they just redirect you to their server, they still have to convince your web browser that your web browser has received a legitimate Facebook.com certificate. And that falls back on that whole certificate authority system that I described before the break. If they can't achieve that feat, then they cannot man in the middle you, even though they've managed to get you to their server. Now, there's still a privacy concern. So notice that, so as far as security goes, DNS by itself isn't really a problem. And solutions like DNSSec are actually not solutions that we need, and they actually cause more problems than they solve. But it is a concern in some sense, in terms of privacy. Because the fact that you visited Facebook.com, that piece of metadata is sent in the clear with DNS. So there's this project called DNS-crypt. What is DNS-crypt about? It simply creates an encrypted connection to the DNS server you're talking to, so that when you say, what is Facebook.com, that question is encrypted. Over that encrypted connection, you are given the IP address. And here again, we run into another problem with privacy. Because when DNS-crypt gives you the IP address to Facebook.com, you then have to use that IP address to connect to Facebook.com. And the fact that you're using Facebook's IP is still publicly known information. And if you're concerned about that, you have to use something like a proxy, like Tor or a VPN, to conceal the fact that you visited that website. But from a security standpoint, there's not much of a problem with DNS as long as you can do HTTPS. And when you do HTTPS, you have that little concern of TLS man-in-the-middle attacks. So let's move on to the solution. How can we solve this problem? In 2011, Aaron Schwartz wrote a blog post called Squaring Zuko's Triangle, where he described how the blockchain can be used to solve a host of problems, including many of the ones that I just described today. He was one of the first to realize that the blockchain can be used to create a system that had been previously thought to be impossible. This assertion that I'm about to describe is called Zuko's Triangle, named after Zuko Wilcox. It asserts that in any naming system, in any global naming system, you can have only 2 of 3 properties. You can either ask for security and decentralization, but then you're not going to get human readable. You're not going to have human readable names. If you've ever wondered why Tor secret services have these weird name things that look like Bitcoin addresses, That's because they're dealing with Zuko's triangle. And they went for security and decentralization, but they couldn't get human readable. Well, with the blockchain, which is fundamentally just a secure, decentralized database, distributed also around the planet, Aaron Schwartz pointed out that you can actually have all three of these properties in a global naming system, which is what DNS is. It's a global naming system. A global naming system that has human-readable names, a little bit of decentralization, not too much, and no security whatsoever. Because the blockchain is this ledger that is only appendable, you can only write to it. It allows you, it can be used, and because it's protected by proof of work, it can be used to make assertive statements like, I registered Mozilla, no, okay, let's do Mozilla.bit. About 3 months after Aaron Schwartz posted that blog post, squaring Zuko's triangle, the first fork of Bitcoin was announced that came and did this, called Namecoin. And it allowed you to register domains on the blockchain using Namecoins. And the canonical TLD that they used was called .bit. So you could register .bit domain names on Namecoin. And this was really cool because it marked another first, in some sense, in internet history. This concept of real ownership. Up until Namecoin, we did not have real ownership on the internet. Maybe there were some other systems, but Namecoin really ingrained this concept of real ownership. Actually, Bitcoin gave you real ownership of your money. And before then, people had to rely on third parties, not themselves. So you could not, with Bitcoin, prior to Bitcoin, you had to rely and trust on PayPal, on the entire banking infrastructure, etc., to not mess with you, and to keep your funds, secure, and not take them away from you. Suddenly, Bitcoin came onto the scene, and it was possible, all of a sudden, for you to be in charge and to actually own digital currency without having to trust anybody else. Before, the closest you could get to that was to either take out some cash, put it under a mattress, or to some bars of gold. Now with Bitcoin, it became possible to do the digital equivalent of that. And then with Namecoin, it became possible to do the digital equivalent of having a name, actually owning a name online, that no matter where you went in the world, when you looked up that name, you would get the same piece of information as somebody else on the other side of the world. And that's what the internet effectively is with websites. These are names that are supposed to resolve to the same thing no matter where you are in the world. So real ownership, however, comes at a cost. It's a double-edged sword. Because with real ownership comes the possibility of real loss. Just like when you have a car that you own, somebody can go break into your car and now it's theirs. And you have to go somehow get it back. Whereas with today's online system, because you're trusting somebody else to maintain the security of your digital assets, your name, for example, most people's identity online these days is oftentimes synonymous with their Twitter handle. And you're trusting Twitter to allow you to speak your mind online, to not, take your account away from you, to not censor you. You're trusting them to be a good steward of your name. And so you're actually borrowing a name from Twitter, just as you rent your website from ICANN, which is the international governing body over DNS and that whole naming system. And there are in the news every now and then pops up a story about how such and such a website had its domain name seized, taken away from them, from the owners. Namecoin stops that. Namecoin stops seizures of domain names. Because the only way to seize a Namecoin domain is to either go to the person's house, get their laptop and steal their private key, or hack into their laptop and steal their private key. Much more difficult than just saying, hey, we're the government, so we can do whatever we want and steal people's stuff. But Namecoin doesn't just solve the problem of domain seizures. The concept of using a blockchain to do a secure, decentralized, distributed key-value database solves so many other problems. It actually solves the man-in-the-middle attack, for one. So if my computer were running a Namecoin node, it would use the sort of trustless infrastructure and the power of proof of work to retrieve all of the blocks that are Namecoin and look up whatever okturtles.bit's IP address is. But you can do more than just looking up what an IP address is. You can look up somebody's public key. Remember I mentioned that X509 was a form of a public key infrastructure? Well, the blockchain can also be used to do public key infrastructure. But it can be done in a way such that you trust the security, you're not relying on an untrustworthy third party for your trust. You're trusting the security of the system itself, proof of work in the case of Namecoin. And that's several levels above that. So once you have a blockchain that you can look up public keys for names, human readable names, you can do email just like email is done today, but secure. So somebody out there, and I encourage somebody to actually do this. Here's a programming project idea, because I'm not going to do it. I'm just working on the system that makes this possible to do, called DNSChain, which I'll get to next. You can have the following user experience. I want to send an email to greg@okturtles.bit. So I just type in greg@okturtles.bit into my email client, type my message, and send. That's the user experience that people are used to. That's how email is supposed to work. But with the blockchain, you can have the client software automatically retrieve the correct public key at this point in time. The person you're communicating with can update their public key in the blockchain, can recreate their private key, recreate their public private key pair as much as they want, and update the fingerprint that's stored in the blockchain. And so client software will always have the right key, as long as you know what their actual email address is. The same goes for secure text messengers. So Apple, for iMessages, can provide the same user experience that people are currently used to with iMessages. And they can be truthful in their marketing copy and say that they cannot be coerced into spying on their customers. Because right now they can be. Right now the government can go and say, we want you to spy on these people. Anytime they send an iMessage to each other, we know that your iMessages is technically end-to-end encrypted, but because you're acting as the public key infrastructure, and because you're the one who's responsible for distributing public keys, we just want you to substitute the user's public key for ours, please, and then tell us what they're saying. So Apple can be truthful when they say that that scenario cannot happen if they were to switch to using a blockchain-based approach and store users' public keys in a blockchain. The user doesn't ever have to know that this is happening, but they benefit from real end-to-end security. And the same can be done with websites, with HTTPS. Instead of relying on a bad apple out of thousands of bad apples, maybe I shouldn't be that mean, but they can rely on data that almost nobody can mess with. And actually, let me go into that a little bit. There's the 51% attack, right? What can the 51% attack do? Notice that not even the 51% attack can change the information that's in the blockchain. So I can store my public key for my email in the blockchain, and somebody can 51% attack the network, and it doesn't really bother me too much because they cannot change that entry without my private key. All they can do is double spend and censor the network, prevent updates from coming in. So potentially they can wait for my name to expire in the blockchain. In Namecoin, it's about, I think it's a little over half a year, the expiry. Like if you don't do anything, if you don't send a transaction to the blockchain, it'll expire after about half a year in Namecoin. And the rules can be different for different blockchains. And by the way, Namecoin isn't the only one that's doing this. Recently, some of you might have heard of a company called OneName, released a project called Blockstore, which is a key value database that uses the Bitcoin blockchain. What they do is they simply you've got the Bitcoin blockchain going along, and they use a very small piece of small amount of data. What they do is they just take a fingerprint, a hash, and they store it in a transaction in the blockchain. And what these hashes are they are keys into a DHT. I mean, this is often how a DHT is represented. You know, it's sometimes it's a structure that's circular. Sometimes it can be done in other ways. And it's the same kind of technology that powers BitTorrent. And then they can store, arbitrary amount of information. The only concern with this model is that there is an availability attack. Like somebody can Sybil attack a DHT and make the data unavailable, and that's about it. But as far as security goes, if you're able to access the data, then you've got the actual data. Yes?
Yeah, I had a question on the block store, the DHTs that they're storing. Do you know where they're storing the DHTs? Because
they're using Kademlia or something like that, is the DHT thing that they're using. It's a DHT client.
So the example that you gave about sending over an email using the blockchain to essentially pull a public key of the person that you're submitting it to, that still means the person that's receiving the email has to manage their private key and store it somewhere, right? And so essentially, be it their laptop or some third party that they trust to store their private key, that leads into another discussion of, well, shit, I'm not someone who's necessarily adept at security of my laptop or at a level where I can protect this private key. So then, right?
Yeah, I get what you're saying. Okay, so that's an excellent question. Thank you for bringing that up. The concern was, well, you're talking about getting rid of users having to manage and deal with public-private key pairs and all of that, but ultimately, there is this private key that they have that they use to decrypt messages and sign messages. Well, doesn't that introduce the problem of what you described earlier a few moments ago, where if they lose the private key, they're kind of screwed, or they have to deal with keys again, and that just makes the whole system unmanageable? That's a great question, and there are solutions to that. So, one solution that I'm